Uh, Good evening, Troy. How are you doing today?
I am fine. Last time I was researching about data science and I found a term, Capstone project.
Okay, so you are curious to learn about what is Capstone projects?
Yes,
Okay, uh, yeah, I appreciate your interest. So today, I have designed something keeping in mind the data science Capstone project, right? And the project title would be Prediction of the Heart Disease through the Power of Data Science, how we can compete and win with these projects and how we can predict the heart disease, right? As usual, just give us a little background of yours, Rohi.
I am a student who studies in 8th class. I was researching about data science after our last class and I found a term, Capstone project.
Okay. So which of the syllabus you follow in the
I follow
classroom?
the syllabus CBSE.
Okay, wonderful. So you must be hearing a lot about all around the data science, machine learning. Although we completed the two episodes, the introduction to data science, then introduction to machine learning. Today is our third episode, and since like we have been here in the data science, just to get a sense what could be a capstone project or what could be a project for a data science. As usual, let me have this privilege and opportunity to introduce myself. My name is Viswajit Naik. Uh, I bring over 20 plus years of experience in the domain of data science, machine learning, artificial intelligence. And I represent an organization called Great Analytics India Private Limited, based in Delhi, India, right? And I play a role in Grid Analytics as a Director, Advanced Analytics and Data Science. This is my coordinates in the left-hand side, right? So any of our viewers of this video, if they have an interest, they can have a touch base with me, right? So what is a capstone project, right? The capstone project is basically the integration of knowledge, right? The capstone project requires students to integrate and apply the knowledge and skills they have acquired during their academic journey. This often involves drawing upon coursework, research, and practical experience to address a specific problem or question, right? What are the examples of a capstone project? Examples of capstone projects can vary widely. They might include a comprehensive research paper, developing a business plan, designing and building the prototype, creating a software application, conducting a community service project, or producing a creative work such as a film, a piece of art, or performance. Ultimately, the purpose of a capstone project, this is very important. The purpose of a capstone project is to provide students with an opportunity to synthesize their learning, showcase their expertise, and demonstrate their readiness to apply their knowledge and skills in their chosen profession or academic discipline. Fine. So here, since we have completed the two episode on introduction to data science, introduction to machine learning, so our purpose now, how we can apply the skill or the foundation we have built on this topic, right? So as our title suggests, the data science projects title as prediction of the heart disease. So whenever we undertake any of the projects under data science means it could be from statistics, machine learning, artificial intelligence, right? Decision science, neurocomputing. When we undertake any of the projects under the data science, there is a project framework as defined by one of the data mining community. And data science is nothing, but that is an extension or that is an upgradation from data mining. So the data mining fraternity or the community, they have developed a framework in order to make the simplicity of the projects, right, in the name of the CRIPS framework. And the CRIPS denotes to cross-industry standard process for data mining. So once you follow this project framework, your chances of completion and winning of the projects will be more compared to any other project. So, as our title suggests, the data science project is to provide students with an opportunity to synthesize their learning, showcase their expertise, and demonstrate their readiness to apply their knowledge and skills in their chosen profession or academic discipline. Fine. So here, since we have completed the two episodes on introduction to data science, introduction to machine learning, in absence of this framework, right? What the breakdown of this CRIPS framework: business understanding, data preparation, modeling, evaluation, and deployment. So we are going to experience in a couple of minutes how we can follow this framework, how we can complete our project titled as a prediction of heart disease using the data science. But whatsoever the activities we carry out under this framework, broadly we carry out the four type of analytics. I'm showing you an infographics. So whatsoever the activities or sub-activities we will be carrying out during our projects, that we will be applying the four type of analytics. That is the descriptive analytics, right? What happened, right? The purpose of the descriptive analytics is to get a sense or to get an understanding about the nature and the characteristics of the data sets. Moving up, we have something called diagnostic analytics. So this is more into a variables or what are the rules which contributes to the more causes. Then moving up, we have something called predictive analytics, right? For the forecasting, right? What we saw the like regression classification and the prescriptive analytics, right? So once we see something undesirable or some happen, we are predicting something which will be uh, much of our concern, right? So how we can control that event to happen? So we can prescribe some of the corrective measures in order to control that undesirable instances. Fine. So we'll also experience how we can carry out all these activities or during these capstone projects. So let's, right? So as usual, I will be using a software called Statistica for these projects. And as you are aware, the Statistica happens to be one of the leader in data science, machine learning, artificial intelligence as a platform or as a commercial software. And the Statistica has been uh, in the leadership category, and they have been maintaining this legacy of leaderships. This is the fourth time in a row, right? What you can see here, the TIBCO software or TIBCO Statistica. So let's get into a data set. We have experienced this data set in the previous two sessions also. So the data set consists of, right? The data set consists of your can you tell me like what is the data set? What is the number of rows? What is the number of columns?
The data set consists of 17 variables, which means columns, and 462 cases, which means rows.
Wonderful, right? So this is the volume of the data we are going to dealing with. And these column are basically the various parameters, all right? The various medical parameters, social parameters, or the medical history, right? And these rows consist of basically the number of patients they have visited to a doctor. Fine. Okay. And suppose we scroll down, out of these 17 variables, we have one column called coronary heart disease, right? You see, the coronary heart disease has been labeled as present, absent, present, absent, or the label with classes. So, since we have discussed in the last, so what is the type of the problem we are going to solve here? It is a regression
The class.
problem.
It is a classification problem.
Okay, why it is a classification problem?
Because we are classifying on basis of the data given.
Okay, the basis of the data given and my target variables are labeled in classes. So this is basically under the supervised learning family, right? So what the projects we have, the Capstone projects we have in hand, keeping in the backdrop the CRISP framework and keeping in the backdrop the four type of the analytics, we will build a model building, right? So once we receive the 463 number of patients, new data, right? The 463 number of patients, new patient, new data, right? So what will not be available, one column will be missing in the 463 number of patients, right? So what would be that? What would be missing in the 463 number of patients?
The classification, the coronary heart disease, absent or present.
Yeah, basically the outcome will be missing in the 463 number of patients that we are going to predict, right? The number 3, the state 3, moving up in the predictive analytics that we are going to predict, right? And on the basis of the prediction, suppose we predict something unusual or undesirable, then we can prescribe something in order to control that event, right? So let's get into, so we have developed an interface. We have developed an interface in the name of and we have developed an interface. You can view my screen, Troy. Can you view my screen, Troy?
Yes, I can view the screen.
What you can view my screen? What is your
The
first?
prediction of heart diseases.
The prediction of a heart disease is some kind of a form kind of thing you view, right? That is one of the interface has been created using Statistica and using the code generation we have created in the C#, right? Because we have one of the very advanced features for code creation. So we have created the code, right, while building our model in C#, right? Under this thing, the prediction of the heart disease, you see something through CART model. Can you make it out what this CART means for?
A classification regression tree.
Yeah, this is the classification and regression tree. This is one algorithm from the decision tree family of algorithm, classification and regression tree. So during the CRISP framework, the model building, we have used the classification and regression tree to build the model. Can you see my pointer? My pointer, I have pointed something where you see a bar graph, and the bar graph defines like age, disease, tobacco intake, age range, so and so. Can you make it out something out of this bar graph? I can give you a hint. This is one of the outcomes for your diagnostic analytics, right? So the root cause analytics.
I am guessing that this is what is the probability that what is the main cause of heart diseases in patients.
Yeah, right. So diagnostic analytics is a type of analytics we apply in order to get a sense which of the variables or which of the parameters which contributes maximum to your outcome or the target or response variable, which in these projects, we have the coronary heart disease, right? So here you see the age disease followed by tobacco intake, age range, tobacco intake, so and so forth, right? So here we see the age is the major contributor to uh, the status of the heart disease, followed by the tobacco intake. Hence, like the age, we do not have any control, right? Because uh, we do not have any control over the age, right? So we can more play around with this thing. So let's get us a sample data. Mind is the sample data is the patient number 463. A new patient has visited to the clinic, right? And in the new patient, we do not have this outcome or the response whether he or she will be having the heart disease or not. So I'm bringing one of the sample data, right? The same data structure or the same number of parameters, right? What we had. And let me check the status. Mind it, now the doctor is not there. Doctor is not available in the clinic. So I am in the reception with powered with this model or with this interface, data science interface. Let me check the status. So once I check the status, I found highlighted in the red this new patient on these parameters, right? He or she will be infected with the heart disease. And what I see, the heart disease present, the heart disease will be present, means there is the result is positive, right? And if the patient asks me or the relative of the patient asks me, what are the probabilities or what are the confidence level you can claim or you have the evidence to suggest you have these uh,
May
I
I
would,
ask a question?
yeah, sure, please, sorry.
On what basis can we claim this percentages of absent and present?
Yeah, that is a very good question. In fact, Roy, yeah. Suppose I go into the backdrop of these the CRIPS framework, right? Let's go into the CRIPS framework. We see whenever we have been dealing with the projects, we have something like the modeling. Like the modeling we saw, the technique we have used under the modeling is the CART, classification, regression, tree. Then we have something called evaluation, right? So we apply the various evaluation technique in order to evaluate the accuracy of the model. The evaluation technique could be, since it's a classification problem, right? We can apply F1 score, confusion matrix. Then we have ROC, AUC, curves, right? So and so forth. So on basis of this evaluation, right, we got this 78% probability, or we claim the accuracy of this model is 78%. 78% chances are there this person will be have the positive or the heart disease. So again, if I go, so as of now, we have completed till the prescriptive analytics, right? So as a doctor, I need to recommend something in order to control that undesirable event, right? These heart disease present. So we wanted to prescribe some control in order to change the status from the positive to negative, right? The prescriptive analytics. So once I go here to my model, right, and I observe during my step of the diagnostic analytics, I see the tobacco intake was contributing maximum to the status of the heart disease. So what I can do, I can change the tobacco. I can prescribe the patient, why don't you quit the tobacco? So let's quit the tobacco 0, tobacco intake level, I put the low. Now let me check the status after prescribing something to quitting the tobacco and tobacco intake. Let's check the status now. Can you observe something, Troy?
Yes, I do observe a change in the data.
Not data. You see in the right hand pointer, earlier the heart disease was present, and now the status of the heart disease has been changed from present to absent. The status changed, right? So this is the way, like through the power of data science, in absence of a doctor, also you can predict the outcome of the heart disease, right? So you're not necessarily, you need to have a qualified doctor in order to do some kind of the prediction for the heart disease. So this is the capstone.
Rather than changing a major part or major role in this heart disease, why don't we change? Can we change the things that play a smaller role in causing heart diseases
Yeah,
to
then you can do all the
get
permutation,
the same?
combination, all the simulation you can do, right? So this is the part of the research, right? Depending on your outcome of the research, right? So you can play around, right? What kind of the parameters, like suppose you see, right? Suppose the patients will be very, very adamant and he or she is not willing to quit the tobacco, right? So you can recommend like for some time, because for uh, uh, for this intoxication, sometimes it is very difficult. So you can ask them, like you can have one tobacco, let's see, per day. Let's see whether the status will change or not. No, right? So if suppose I put a two tobacco, let's see. No, the two tobacco is not working, right? So you can ask if the patient is very adamant, right? You can ask them, although it's not a good advice, it's a bad example, right? But you can ask them to get into one tobacco, fine. So this is the way you can do a lot of simulation, right? Or you can change the different parameters in order to do your capstone projects.
From the following data type, can we also suggest medicines?
Yeah, the same, like suppose you have the data we have. If suppose you wanted to put a column in different the medicine or the different doses of medicine, right? You can very well identify during your diagnostic analytics which of the medicines are working well, right? What is the doses you are working? So there are a variety of the analytics you can perform, right? So here you need to whatsoever the parameters you would like to include here, you can add so, right? Even what we saw in the diagnostics, right? Because this is more into a cleaning data, right? Suppose the data is not clean, these are the activities you need to carry out during the projects. As you see, the Statistica, the software we have been using, it gives most of the algorithm to solve the classification problem, like general classification, regression tree model, chat model, interactive trees model, boosted tree classification, random forest, Mars lines. We can apply the neural network to approach and solve the same problem. In fact, we had done that, right? But after applying all these possible algorithms to solve the classification problem, we found that the classification and regression tree is working fine. So we have machine learning, right? Under the machine learning, we have also the capable algorithm which can be applied to solve the classification or regression problem. Support vector machine, Navier classifier, k-nearest neighborhood, so on. So how did you find Troy? Does it sound interesting to you?
Yes, very much.
Okay, wonderful. Uh, right. So this is one of the Capstone project, right? So next time, and if you, if our viewers, because this is one of the initiative we have taken. Suppose you, if you'd like to, we will describe all the details along with the data set in the description section of the YouTube video, right? And we would urge and appeal to our viewers, you feel free to subscribe our YouTube channels, and you find very, very interesting the interesting video, advanced reading materials. We have been managing one TIBCO Statistica group where we poll every day some kind of the very, very topical questions for the data science interview preparation. So there is a lot of materials are there in the YouTube channel and in the LinkedIn Statistica group, TIBCO Statistica group, right? So we urge and appeal to all the viewers to subscribe our video and encourage more to prepare such kind of the topical video in the domain of data science, machine learning, artificial intelligence, right? Okay. Thank you, Troy, for your time, and thank you for your uh, the interest, right? We continue to make such kind of the video. Thank you very much. Signing out for today. Bye bye. Take care. May God bless you, Beta. Bye bye.